Good afternoon, my name is Damian George and I'm going to be using Kirchhoff's junction rule and loop law to demonstrate a circuit problem. The junction rule basically just means that the sum of currents going into a junction is going to be equivalent to the sum of current going out of the junction, and loop law is going to be saying that the potential differences in voltage change is going to be equal to zero in a closed loop in a circuit. Okay, so in this circuit we were given two batteries. Battery number 1 had 30 volts, battery number 2 had 9 volts. We were given 3 resistors and 3 currents through the resistors. So we need to find I2, I3, and R3. We were only given current 1, resistor 1, and resistor 2. And we have to use the equation V equals I times R, which is your voltage equals your voltage is equal to your current times resistor, to find the missing information. So let's start off. First, we need to go from the 30 volts, we need to go through resistor 1, and we're going to go through resistor 2 and get back to battery number 1, and we're going to do this side of the circuit, and we're going to utilize Loop's law, which we know when we get back we have to have 0 volts at the end to remain in accordance with Loop's law. So let's find the voltage drop first going through resistor 1. 30 volts, we know what our resistor 1 is, we know what our current 1 is, so we're going to use V equals I times R. Okay, we're going to use V equals I times R. And it's going to have your 8 ohms times your 2.5 amps, and that's going to give you 20 volts. So you can lose 20 volts here going through resistor 1. 30 minus 20 equals 10. So once we get through resistor 1, we're going to have 10 volts left. Now to go through resistor 2. So here we don't have our current. That's okay because we're going to use V equals I times R. And we're just going to do a little substitution here. We're going to do our voltage divided by our resistor to get our current. So it'll be 10 divided by 5 is equal to 2 amps. 2 amps is going to be your I2. Let's check our work real quick. 2 amps times the 5 ohms, which is the resistor number 2, is equal to 10. We have 10 voltage left after we get through resistor 1. 10 minus 10 is equal to 0. We're at 0 when we get back to the battery. We're in accordance. Okay, now that we've figured out what I2, we have I1, now we can use that thing called the junction rule. Junction rule is I1 minus I2 minus I3 equals to 0. Well, basically, we can simplify that to I1 minus I2 is equal to I3. I1 is 2.5 amps. I2 is 2 amps. I1 is 2.5. 2.5 minus 2 equals 0.5. 0.5 amps is your I3. Now that we've figured out what I3 is, now we can incorporate that, and now we can find what the resistor 3 is because we can plug it into the equation now. So let's do the big loop now. We're going to go all the way around. We're going to incorporate the second battery as well. Let's use what we know. We're going to start off with 30 volts. 30 volts coming from battery number 1. We know we're going to go through resistor number 1 here, and that's going to be, we're going to lose 20 volts because that's going to be your 8 ohms times your 2.5 amps. Now that we've lost 20 volts from that 30, we have 10 volts. Now we're going to go all the way around, and instead of going through resistor 2, we're going to go through resistor 3 because we're going around it. We're going through resistor 3, we know we have 10 volts. We don't know what R3 is, but we know what I3 is now. So all we're going to do is we're just going to plug it into this equation, and we're just going to isolate for R3. So we're going to do 30 minus 20, which is a 10. 10 plus the 9 volts, which is coming from battery number 2. So that's going to give you 19 minus R3 times I3 is equal to 0. It's equal to 0 because we are using Loop's law, and we know it has to be equal to 0 at the end of the closed circuit. So now let's keep isolating. Negative, we're going to move the 19 on the other side, so 19 is going to become negative. So it's going to be negative R3 times I3 is equal to negative 19. And now we're going to divide negative R3 to isolate R3 by itself. We're going to divide by I3. I3 is the 0.5 amps. So negative 19 divided by 0.5 equals negative 38 ohms. So negative R3 is equal to negative 38 ohms. Now let's isolate R3, so get rid of that negative. So divided by negative 1, divide the other side by negative 1. R3 is equal to 38 ohms. Now let's check our work. We're going to check our work. 38 ohms times the current, which is I3, 0.5 is 19 volts. Right, so let's go back from the top. 30 volts starting from battery 1. Go through resistor 1, we lose 20. 30 minus 20 is 10. 10 minus the volts which we're going to lose in resistor 3, 19. 10 minus 19 is negative 9. Now we're going to battery number 2. Battery number 2 has what? 9 volts. Negative 9 plus 9 equals 0, which means we are in accordance with the loop law. We have found I2, we have found I3, and we have found resistor 3. That's it. Thank you.